Welcome to the Web Security Bootcamp channel, a series of SQL injection tutorials based on labs from the PortSwigger Web Security Academy. In this video, we'll solve the lab called SQL Injection Attack, querying the database type and version on MySQL and Microsoft. The goal of this lab is to exploit a SQL injection vulnerability in order to retrieve information about the backend database. More specifically, we want to identify the database type and its version. This is an important step during SQL injection testing because different databases support different SQL syntax and functions. Once we know which database is being used, we can craft payloads that are specific to that system. In this lab, we'll use a union-based SQL injection technique to extract the database version string, which also reveals the database type. Before we begin, a quick reminder about ethical responsibility. This content is provided strictly for educational purposes and for use in authorized security testing environments only. Never attempt to apply these techniques to systems without explicit permission. On this page, we can see the lab description and the objective of the exercise. I'll leave all the necessary links for this lab in the video description so you can follow along. The application contains a SQL injection vulnerability in the product category filter. This means that the category parameter used in the SQL query is not properly sanitized. Our task is to exploit this vulnerability and retrieve the database version string. The lab specifically mentions that the backend database is either MySQL or a Microsoft SQL Server. To solve the lab, we'll need to perform a union-based SQL injection that returns the database version as part of the query results. In the next step, we'll open the application and start testing the category filter for SQL injection. First, I'll send a normal request to see how the application behaves. The server responds with a 200 OK status, which means the request was processed successfully. Now we can start testing whether the application is vulnerable to SQL injection. A common way to test this is by inserting a single quote followed by a comment. Here, I start by adding a single quote and the double-dash comment sequence. But the server responds with a 500 error. Next, I try replacing the double dash with the hash symbol, which is another way to start a comment. This time, the request works. This behavior can suggest that the backend database might be MySQL because MySQL supports the hash symbol as a comment. However, this alone is not enough to confirm it. To be certain, we need additional checks such as retrieving the database version. There is also an important detail when working directly in the browser. Browsers treat the hash character as part of the URL fragment, which means it is not sent to the server. Because of this, we must encode it as %23 so the comment actually reaches the application. So when working from the browser address bar, we use %23 instead of the hash symbol. If the application behaves differently after inserting these characters, it can indicate that our input is being interpreted as part of a SQL query. Now that we've confirmed the SQL injection vulnerability, the next step is to determine the number of columns in the original query. A common method is to use a union select statement with null values. On the page, we see two main display elements, the title and the description text. This might suggest that there are two columns in the output, but this is only a preliminary hypothesis. The actual number of columns needs to be confirmed through testing. In the payload, I add two null values like this. Here we try single quote union select null, null, followed by a comment. For more details on how to determine the number of columns, I have a separate video on my channel. You can find the link in the description below this video. We then increase or decrease the number of null values until the query executes successfully. When the number of values in our union statement matches the number of columns in the original query, the page returns a valid response. After identifying the correct number of columns, the next step is to determine the data types of those columns. We can test this by replacing the null values with strings, for example a B, C, and D, E, F. If the query executes successfully and the strings appear in the response, it means those columns accept string data types. I also have a separate video on my channel explaining how to finding a column containing text. You can find the link in the description below this video. Here, a B, C, and D, E, F appear in the table cells. This is no longer just a reflection of the request string, but data being rendered in the application's response. Now that we know the column structure, we can try to extract information from the database. In this lab, the goal is to retrieve the database type and version. To do this, we can use the double@version variable, which returns the database version string. This variable exists in both MySQL and Microsoft SQL Server, so the query works in either database system. When the query executes successfully, the response returns the version information. From this result, we can often determine both the database type and the version. For example, a version string like 8.0.42-0 Ubuntu 0.20.4.1 clearly indicates MySQL running on Ubuntu. If the backend database were a Microsoft SQL Server, the response would typically contain a string such as a Microsoft SQL Server followed by the version number. Because of this, we determine the database type by looking at the version string and other characteristics of the query behavior. Before finishing the lab, let's quickly recap the steps we used to exploit this SQL injection. First, we sent a normal request to understand how the application behaves and confirm that it returns a 200 OK response. Next, we tested for SQL injection by inserting a single quote followed by a comment, which allowed us to confirm that our input was being interpreted as part of a SQL query. After confirming the vulnerability, we determined the number of columns in the original query using a union select statement with null values. Once the column count was identified, we tested the data types of the columns by replacing null values with text strings. Finally, we used the @version variable to retrieve the database version, which allowed us to identify the backend database system. By following these steps, we successfully extracted the database type and version, completing the objective of the lab. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.